Welcome back to BotAlpha. In this video, I'm going to show you how to build a liquidation tracker for Aave money market. Okay, let's dive straight into it. For this, we need an RPC provider, and I chose to go with Infura, which is now part of MetaMask. So I can just sign into my developer account. Okay, let's create a new API key. We'll call this Aave liquidation tracker. And for this, let's do mainnet. Now let's go back to our repo. I haven't done anything new since the last video, so let's go into our projects folder and the money market liquidation tracker, create a new file and call it aave.py. Okay, and then before we do that, I want to change this tokens.json file to be in a format like this. The reason I want to do this is because in each chain there could be different networks. Like we could have mainnet, and then we can have a testnet like Sepolia, for example. And so I want to separate between them like this. Okay, now that we have done this, let's go here and so what I've done is in my repositories folder I have cloned the Aave core library. This repo, just click on code and copy this, come to your terminal and do git clone and paste in the URL. Once you have done this, you can go inside the Aave v3 core folder and do cursor dot, or if you use VS Code you can use code dot to enter this file. Once you do that, this repo of Aave smart contracts will open up. Now we want to find the function which is used when liquidating users. And so I do Ctrl+Shift+F or come into this tab and I search for functions called liquidation call. So this is the interface and I can't see much what is happening here, and so I go into the pool.sol where this interface is implemented. I can see that we go inside the liquidation logic smart contract and call this function. So let's see what's happening inside here. So in order to track liquidations that have happened, it's easy to track the events that were emitted on the blockchain instead. So as you can see at the very end of this function, when everything else has happened, all the tokens have been transferred from the user to the liquidator, etc. This liquidation call event is emitted with these parameters like the collateral asset, debt asset that was used, the user that was liquidated, and then the account that liquidated that user, etc. I can also search for docs on how liquidations happen. When calling the liquidation call function, you must know the user, know how much debt to cover, and once their health factor goes below 1, then you can call this function. Yeah, to know whether their health factor is below 1, we can call the get user account data function. Yeah, okay. So I copy this and then we go back to our repo. Oh, I've already pasted this here, and then I tell to the AI agent, this is the event definition for the liquidation call event on Aave. I want you to build a script which tracks liquidation events emitted between specified blocks, and it should write me a function. Let's send it. And I want to specify that I'm using the HTTPS endpoint of my RPC provider. Your script is now set up. Replace with your provider URL. Call the track liquidations with your desired block range. Return the list of decoded events. Okay. We accept. So by default, this is not a great Python script. Like for example, it has only put the API for the liquidation call event, but instead we want to put the whole Aave smart contract API, because in later parts of this project we are going to use we might use other events or functions. So for that I'm going to go to Everscan. Oh, actually, Aave deployed addresses, and Aave has this addresses dashboard. I'm on the Ethereum core market, and the name is pool. So this is an initializable, immutable proxy contract. Now, I don't want the ABI of this because if I get the ABI of this, it won't have the functions and events in its ABI that I want to access. Instead, what this proxy function contract does is it points to the actual implementation contract. This is done because smart contracts are immutable. So once they're deployed, you cannot change them, you cannot delete or remove them from the blockchain. So instead, you can deploy these, which are the actual contracts that are used on the Aave web app. And whenever there is a security vulnerability and they need to use a different contract, they just change the implementation URL. As you can see here. So instead, I want to read as proxy ABI for the implementation contracts previously. Yep. So I want to access. This is the actual smart contracts of Aave, and here I need to find. So this is pool.sol, and to get the ABI, it's at the very end. We have bytecode, contract creation code, and contract ABI. I copy this. I go into the ABIs folder, make a new file and call it aave.json, and then I save it. Now this is not in a great format. As you can see, all of this JSON is on a single line, which is not great. So there we go. Python json.tool, and I need to go inside the core and ABIs folder, and inside this folder I have aave.json. I want to move this into temp.json. Like I want to prettify this using the json.tool function, and move the prettified JSON into temp.json, and then move that into input.json in the next step. Sorry, not input but Aave. The reason we are moving it in the second part is if I do aave.json and then move it into aave.json, that won't work. It will give me an error. And there we go. And core projects. So in the root of this repo, I create a new folder and call it scripts, and then we copy this, make a new script called prettifyjson.sh, paste this here, and yeah, this is how I use it. We need to make it executable. Okay, done. Now whenever I want to prettify the JSON of an ABI of a smart contract, I do it like this. Okay, perfect. And here we can find the liquidation call event. Now I want to retrieve it from the ABIs folder. So what I can do is with open and now Aave ABI is loaded. And here I can do from core.constants import Aave ABI, and this will point to that. Would I be able to do BotAlpha dot core.constants? Could not be resolved. Okay. And I want to set my RPC URL and in the constants as well. Actually, my API key is different from the URL. So here I can do MetaMask API key, and I paste that in, and then inside the constants, this is the provider URL. Pool address. Okay, we have tokens, and then I also want contracts.json, and in here we have, for example, Ethereum, and then mainnet, and then inside mainnet we have Aave pool, which is at this address. Okay, we have contracts. Now I also need to access my API key by retrieving it from the .n file. Yeah, let's do it in here as well. applications, web free connection. Okay, I also want to create the web connection inside my constants. Okay, RPC URL plus the MetaMask API key. Event API is inside my contracts, Ethereum mainnet Aave pool. Lending pool address is inside my this is the contract address, and the ABI is Aave ABI, sorry. And let's also put this assertion inside constants when it's created. And ABI signature, is this the correct signature? Free address to uint. So it will be called event liquidation call. Free address, 2 uint, 1 address, 1 bool. Okay, it's the correct one. From block, start block, 2 block is end block. This is the address, these are the topics. And then how is it decoded? We call the decode event of the web-free object, block, collateral asset, debt asset, etc. Okay, nice. Let's run this. Make sure you're running from root, and then okay, add project root to Python path at the top of tracker. No, this is not good. Okay, I think I need to do this. Did I not activate the virtual environment? Okay. Okay, still doesn't work. Pip install. Okay. Sometimes the package name is different, so I needed. So I checked. Okay, it's installed now. Find packages. Okay. Okay, so there were no liquidation events between these block numbers. Let's check the pool for events. Okay, I need to go to the actual contract. Here, events, supply, borrow. Okay, let's search for liquidation call events. Event borrow address free address. This will complicate stuff. Let's try another event. Okay, free address, one unsigned integer, and then another one. Free address, unsigned integer, and this one was 16 bytes. Let me check. Yep. Okay, now let's try this. It still couldn't find. Maybe the address is different. We gave 947. Which one was 947? Maybe we need to give this address instead. Okay, now let's try. Okay, there we go. Oh, okay. We need to create the contract instead. Okay. Contract event ABI. This doesn't even get used. Okay, so between these two block numbers there were this many supply transactions, and we can see the reserves that they supplied for the address that they supplied on behalf of their actual address, the referral code that they used, and how much of this token that they supplied. Now we can replicate it for our liquidation call event. Free address uint 256, address and a bool, signature hash, okay, let's try this. So there were no liquidation events during these blocks. Let's go back a bit further. Oh, and it found one liquidation event. This was the collateral, this was the debt token, this was the user that got liquidated, and this is the account that liquidated it. And yeah, so this is how we can track liquidations on Aave.